Hi guys, today we're going to be talking about how to do circuits. Today we'll talk about not only what equations to use, we'll talk about how to do a series circuit, a parallel circuit, and how to do a combined series and parallel circuit.
There are three main equations you're going to need to know for circuits. The first one is Ohm's law, which is V equals IR. V stands for voltage, which is measured in volts. I stands for current, which is measured in amps, and R stands for resistance, which is measured in ohms. The second equation you're going to need to know is P equals IV. P stands for power, which is measured in watts. I stands for current, which is measured in amps, and V stands for voltage, which is measured in volts. And the last equation is 1 over R1, resistor 1 resistance, plus 1 over R2, resistor 2's resistance, equals 1 over RT, which is the total resistance of the circuit. This equation can only be used in parallel circuits.
As you can see here, this is a series circuit, meaning the current has to go through all of these resistors before it comes back to the battery. And here we have a VERP chart that's already been filled in with the givens that the VERP chart gives us. So the voltage of the total battery is 125, and the resistance of resistors 1, 2, and 3 has been given to us. So for a series circuit, to find the total resistance, you just add the three numbers that you have been given together, which in this case equals 100 ohms. And once you've found this number, we know that V is equal to IR, so we can divide that to find that I is equal to 1.25 amps. And because this is a series circuit, current is the same throughout the entire circuit, meaning that all resistors have a current of 1.25 amps. And this allows us to find the voltage because we just multiply I and R together because V is equal to IR. So here, 1.25 times 20 gives us 25 volts. And here, that gives us 37.5. And 50 times 1.25 is 62.5 volts. And to finish the VERP chart, we just have to find the power in each resistor, which is the equation we use to find that is P equals IV. So this one would be 25 times 1.25, which is equal to 31.25 watts. And here, this is equal to 46.875 watts. And here, 1.25 times 62.5 is equal to 78.125 watts. And our total for the circuit would be 156.25.
So now we are going to be teaching you how to make a parallel circuit. So if you look over here, we have 120 volts and it goes this way and it goes through either one of the resistors. So how it works once you go to the VERP chart, on a parallel function, the voltage is always the same for all three of them. So the voltage is 120, so we write 120 here for each of them. So your next step is you should take 1 over 30 plus 1 over 30 plus 1 over 40 equals 1 over RT. And if you do the math, you should get 10.9. So now we have 120 here, and so the equation V over R equals I. So if you do 120 divided by 30, you get 4. Same thing here. And then 120 divided by 40 is 3. And for this, you add up the I values all here, and then you get 11. And this is true because if you do 120 divided by 11, you get 10.9. So next we're going to solve to get total power. So first we should do 120 times 11, which equals 1,320. And from here, then you multiply 120 times 4, which gives you 480. Same thing here, 480. And then 120 times 3 is 360. And if you add them all up, you get 1,320, which is the total power for this parallel circuit. Thanks for watching.
Hi, right now we're going to discuss how to do a combined circuit. This includes a series and a parallel. So we're going to see the incorporation of both of those right here. So first let's look at our diagram. We start with the battery being right here with 24 volts. The current starts going this way. It runs through the 5 ohm circuit, it splits off into the 4 and the 12 ohm circuit, and it rejoins and comes back through the 8 ohm circuit and then back to the battery. So now let's break down how we're going to do that. Looking at what we have here, we have our 5 ohm circuit listed as resistor 1 over here. We have our 4 and our 12 listed or as a parallel circuit right over there. And they're in they're resistors 2 and 3. And we have our last resistor as resistor number 4, which is right here. So when we're trying to find our total resistance, our series circuits we can just add, but when we're adding our parallel circuits, we have to do 1 over 4 plus 1 over 12 is equal to 1 over RT. So we solve for RT. And when we do that, we get a total of 16 ohms. Now, using our equation such as V equals IR, we can solve for I. And by doing that, we get that total I is equal to 1.5. And using our power equation, we can solve that the total power is 36 watts. So now you've solved the entire total column. So let's break down what's going to happen over here. First, let's start with our current. The current through a series circuit will always be the same. So let's mark those because these two circuits are in series with each other because the current must go through those. For the parallel circuit, it has the option to go through either of those two. So those are both going to be 1.5. Next, if you set these up together as a proportion, and if you do 12 over 16 for this one and 4 over 16 for this one, and multiply them by 1.5, you get 1.125 here, amps, and then you get 0.375 amps for resistor number 3. Now, using our equations such as V equals IR and our power equation, we can once again solve for voltage and power. So 5 times 1.5 is equal to 7.5, and then 7.5 times 1.5 is equal to 11.25. Now we're done with resistor 1. For resistor 2, 4 times 1.125 is equal to 4.5, and 4.5 times 1.125 is equal to 5.0625. Next, 12 times 0.375 is equal to 4.5. Then 4.5 times 0.375 is equal to 1.6875. Then for our final resistor, 8 times 1.5 is equal to 12, and 12 times 1.5 is equal to 18. Now, you always know that you did a circuit right when all of your powers, when you add them all up, they equal to 36. In this case, they do. So congratulations, you've just solved your first ever combined circuit. Thank you for watching.